When I was your age, I was a chemistry major. I got incredibly good at doing titrations. In fact, the extent to which I got good is absolutely outrageous. I learned to use a burette to titrate to get to within literally a quarter of a drop of acid or base added to a solution. I accounted for temperature differences. I accounted for hundredths of a milliliter, I kid you not, hundredths of a milliliter worth of changes in volume being added to a system. And when it was all done, I had developed a skill that was remarkable for the 1940s. Except for I was learning it in the 1970s, making me effectively obsolete in terms of my skill set. And yet to this day, you can watch me do a titration, and you'll see this sort of movement here. You notice how I'm doing this, and I seem to know what I'm doing? It's because for a solid year, this is all I did in an analytical chemistry course, was become one of the greatest titrators in the history of my generation. And then somebody invented this. What you see before you here is the way people actually do titrations these days. Notice there aren't any people around. What you see here instead is an automated process in which we don't measure color changes, yellow turning to red or blue turning to green, where all that's telling us is, oh, it's acid. No, oh, that's base. Instead, what we're actually evaluating using a pH electrode is some subtle changes in the potential across an interface. Now, this is something we're going to learn about in electrochemistry in about 10 lectures or so. For the time being, just appreciate the fact that I've got a way to measure voltage differences sitting inside this electrochemical system. Voltage differences associated with a chemical reaction. So that I'm not just watching, oh, it's acid, oh no, it's base, but rather I'm able to incrementally follow the pH of the solution as it moves along. As a result then, I can sit here and I could put this on a carousel and I could have 100 different samples and I could titrate 100 different unknown samples, and every one of them would be recording its data here on a computer, storing it for me to come back and look at after I'd gone to lunch. I could fire most of the people who used to work for me doing this. All the people who were doing this are replaced by this. I'm getting much more accurate results for a lot less money, and that's why nobody's going to have a job in the future. But, do appreciate what this has done here is allow me to do the following interesting thing. It has allowed me to say, instead of it's acid, 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 it's base, it's base, it's base, it's base, where all I'm doing is going from yellow to red or blue to green. It allows me instead to do this. It says I'm going to add my base, and I'm going to be measuring a pH. And the first pH I'm going to measure is going to be at this particular value here. And using that particular device, I'm going to slowly but surely add milliliters of hydroxide to it. And I'm adding, and I'm adding, and I'm adding, and I'm adding. And yes, it's still acid, it's still acid, it's still acid, it's still acid. But instead of saying it's yellow, it's yellow, it's yellow, it's yellow, it's actually following the pH. It's saying at this particular volume, oh, it's pH 3.8. At this volume here, it's pH 3.9. At this volume here, it's pH 4.1. It follows and follows and follows, and then boom! This big change occurs. This big change occurs because this happened. The moles of acid became equal to the moles of base. And so that's the only data point on this plot, this one right here, which is like when I'm doing my titration curves. It's yellow, it's yellow, it's yellow, it's yellow, it's blue. Except now, I've got an actual pH associated with that color change as I follow the reaction as it goes on. That's a lovely example right there of a titration curve that's been developed. It's a titration curve that I created using this device, this pH meter here. It knew that for every drop of hydroxide that I added, I was reducing the amount of acid, a little bit at a time. 8, 7, 6, 5, 4, 3, 2, 1, 0. Neutral. And then excess base along here as the pH goes up. Notice, in effect, what I've just done here is mimic what takes place in this chemical system, this titration that's occurred, as it goes from being an acid through a neutralization region to a base. And I use that really nice pH meter and that automated titration device to give me the result. What I'm going to do now is to show you how I can develop a thought experiment in which I could draw this curve for you. Not experimentally, but theoretically, based upon what I've learned from chemical equilibrium.